Top 30 Data Analytics Interview Questions and Answers. Data analytics roles require strong technical expertise, business understanding, and problem-solving abilities. These interview questions help showcase your analytical mindset, communication skills, and ability to turn data into actionable insights. 1. What is data analytics? Data analytics is the process of examining raw data to uncover patterns, trends, and insights that support decision-making. Analysts clean, transform, and interpret data using tools like SQL, Python, and visualization platforms. The goal is to understand what happened, why it happened, and what might happen next. Through statistical techniques and data exploration, analytics helps businesses improve performance, reduce risk, and identify new opportunities. In today's digital world, organizations rely heavily on analytics to guide strategic decisions, enhance customer experiences, and optimize operations. 2. What are the different types of data analytics? The main types of data analytics include descriptive, diagnostic, predictive, and prescriptive analytics. Descriptive analytics focuses on understanding past events, while diagnostic analytics explains why those events occurred. Predictive analytics uses historical data and modeling to forecast future outcomes, and prescriptive analytics recommends actions based on those predictions. Together, these approaches help organizations make informed decisions. Many businesses use a combination of these methods to uncover deeper insights, improve efficiency, and guide strategic planning. Mastering all four types ensures you can provide both clarity and actionable recommendations. 3. What is the difference between data analytics and data analysis? Data analysis refers to the process of inspecting, cleaning, and interpreting data to answer specific questions. Data analytics, however, is a broader field that includes tools, techniques, and systems used to perform analysis, build models, and generate insights. Analytics often involves automation, machine learning, and a larger strategic context. While analysis is task-focused, analytics encompasses the entire data lifecycle. Understanding the difference shows awareness of both operational tasks and big-picture thinking, which is essential for data-driven decision-making in modern organizations. 4. What skills are essential for a data analyst? A data analyst needs a blend of technical and soft skills. Technical skills include SQL, Excel, statistical analysis, Python or R, data visualization, and understanding of databases. Soft skills include problem-solving, communication, critical thinking, storytelling with data, and attention to detail. Additionally, knowledge of business processes helps analysts connect insights to real-world outcomes. Analysts must be comfortable working with large datasets, identifying inconsistencies, and presenting results clearly. The role requires continuous learning, adaptability, and the ability to collaborate with cross-functional teams to ensure insights drive effective decision-making across the organization. 5. What is data cleaning and why is it important? Data cleaning involves identifying and correcting errors, inconsistencies, and missing values in datasets. It is essential because inaccurate data leads to misleading insights and poor decision-making. Clean data ensures accuracy, reliability, and consistency across analyses. Analysts use techniques such as handling duplicates, replacing missing values, fixing incorrect formats, and validating entries. Proper data cleaning improves model performance, enhances visualization clarity, and boosts confidence in the results. Without this foundational step, even advanced analyses or complex models can produce flawed conclusions. Clean data ultimately enables organizations to make informed and trustworthy decisions. 6. What is the difference between structured and unstructured data? Structured data is highly organized, stored in rows and columns, and easily searchable using SQL. Examples include financial records and customer databases. Unstructured data lacks a predefined format and includes text, images, videos, social media posts, and emails. It requires specialized tools for processing, like natural language processing or machine learning. Structured data is easier to analyze, while unstructured data provides richer insights but needs more processing. Understanding both types helps analysts choose appropriate methods and tools for analysis, ensuring accurate insights and better decision-making across various business functions. 7. What is a data pipeline? A data pipeline is a series of processes that move data from source systems to destination systems for analysis. It includes data extraction, transformation, cleaning, and loading into storage solutions such as warehouses or lakes. Pipelines may run in real time or batches depending on business needs. Well-designed pipelines ensure consistent, reliable, and high-quality data. They also automate repetitive tasks, reduce errors, and support scalable analytics. Analysts rely on pipelines to ensure they work with accurate and updated data, enabling faster, more efficient insights. 8. What is the difference between a data warehouse and a data lake? A data warehouse stores structured, cleaned, and organized data for reporting and analytics. It uses predefined schemas and supports SQL-based queries. In contrast, a data lake stores raw, unstructured, or semi-structured data in its original format. It offers flexibility for advanced analytics, machine learning, and large-scale storage. Data lakes are more adaptable but require strong governance. Data warehouses are optimized for accuracy and speed of analysis. Many organizations use both, integrating their strengths to support diverse analytical needs and ensure both flexibility and reliability in data management. 9. What is SQL and why is it important for data analysts? SQL is a programming language used to manage and query relational databases. It is essential for data analysts because most organizational data is stored in relational formats. SQL allows analysts to retrieve specific information, filter data, group results, and perform aggregations. It supports data cleaning, validation, and transformation. SQL is efficient, scalable, and widely used across industries. Mastering SQL enables analysts to work directly with large datasets, quickly extract insights, and support decision-making. It remains one of the most in-demand skills for analytics professionals. 10. What is the difference between inner join and outer join? An inner join returns only matching records between two tables based on a specified condition. An outer join, however, returns all records from one or both tables, including non-matching rows. Outer joins include left, right, and full variations. These operations help analysts combine datasets, identify gaps, and derive meaningful insights. Understanding different join types ensures efficient querying and accurate analysis, especially when dealing with complex relational data structures. Joins are fundamental SQL tools and essential for merging datasets during analytics tasks. 11. What is data visualization and why is it valuable? Data visualization is the representation of data through charts, graphs, dashboards, and visual tools. It simplifies complex datasets and helps stakeholders quickly understand patterns, trends, and insights. Visualization supports better decision-making because it makes data easy to interpret. Analysts use tools like Tableau, Power BI, and Python libraries to create visual stories. Effective visualization highlights key findings, uncovers hidden relationships, and communicates insights clearly. It bridges the gap between technical analysis and business understanding, making analytics accessible to non-technical audiences. 12. What are key statistical concepts every analyst should know? Important statistical concepts for analysts include probability, distributions, hypothesis testing, correlation, regression, variance, standard deviation, and statistical significance. These concepts help analysts understand relationships in data, validate assumptions, and make evidence-based decisions. Hypothesis testing determines whether observed differences are meaningful, while correlation and regression reveal associations between variables. Understanding distributions supports accurate forecasting and modeling. Strong statistical knowledge ensures analysts draw reliable conclusions, avoid biases, and interpret data accurately. These foundations are essential for both basic analyses and advanced techniques in predictive modeling. 13. What is regression analysis? Regression analysis examines how one or more independent variables influence a dependent variable. It helps identify trends, quantify relationships, and make predictions. Linear regression is the most common type, while logistic regression handles categorical outcomes. Regression is widely used for forecasting, performance measurement, and understanding key drivers of business outcomes. The technique supports strategic decision-making by revealing which factors most impact results. Analysts must understand assumptions, evaluate model performance, and validate outputs to ensure accurate insights. Regression remains a foundational tool in data analytics and predictive modeling. 14. What is A/B testing? A/B A/B testing is an experimental method used to compare two versions of a product, feature, or process to determine which performs better. Analysts split users into groups and measure differences in behavior, engagement, or outcomes. It supports data-driven decisions, reduces guesswork, and validates hypotheses. A/B testing requires careful design, proper sample sizes, and clear success metrics. By analyzing results, organizations can make informed improvements to user experiences, marketing campaigns, and product features. It is an essential technique in modern digital analytics. 15. What is ETL in data analytics? ETL stands for extract, transform, and load. It refers to the process of pulling data from source systems, cleaning and converting it into usable formats, and loading it into storage systems like databases or warehouses. ETL ensures consistent, reliable, and high-quality data. Analysts rely on ETL pipelines to access accurate datasets for reporting and modeling. Strong ETL processes reduce errors, support automation, and improve efficiency in analytics workflows. Understanding ETL helps analysts troubleshoot issues and collaborate with engineering teams. 16. What is the difference between quantitative and qualitative data? Quantitative data represents numerical values used for measurement and statistical analysis. Examples include sales figures, prices, and counts. Qualitative data describes characteristics, opinions, and attributes, such as survey responses or customer feedback. Quantitative data supports precise calculations and trend analysis, while qualitative data provides context, depth, and explanation. Both types are valuable and often used together to develop a complete understanding of business problems. Analysts must recognize which type of data is appropriate for specific tasks to ensure accurate insights. 17. What tools are commonly used by data analysts? Data analysts use tools like SQL, Excel, Python, R, Tableau, Power BI, and Google Analytics. These tools support data extraction, cleaning, analysis, and visualization. SQL and Python handle large datasets and complex processes. Excel is useful for quick analysis and reporting. Visualization tools help create dashboards and communicate insights. Cloud platforms like BigQuery and Snowflake are increasingly important. The choice of tools depends on business needs, dataset size, and analytical goals. A strong combination of these tools enables analysts to work efficiently and deliver valuable insights. 18. What is machine learning in data analytics? Machine learning involves using algorithms that learn patterns from data to make predictions or automate decisions. In analytics, it extends traditional analysis by enabling more advanced forecasting and pattern detection. Common techniques include classification, clustering, regression, and recommendation systems. Machine learning helps businesses personalize experiences, detect anomalies, improve efficiency, and automate processes. Analysts must understand data preparation, model evaluation, and algorithm selection. While not all analysts build complex models, basic knowledge of machine learning enhances analytical capabilities and supports collaboration with data science teams. 19. What is a dashboard and why is it useful? A dashboard is a visual interface that displays key performance indicators, metrics, and insights in real time. It helps stakeholders monitor performance quickly and make informed decisions. Dashboards simplify complex information using charts, graphs, and filters. They support transparency, alignment, and accountability across teams. Analysts use dashboards to communicate insights, highlight trends, and track business objectives. Effective dashboards are clear, interactive, and tailored to user needs. They play a crucial role in modern data-driven organizations by making insights accessible to everyone. 20. What is correlation and how is it different from causation? Correlation measures the strength and direction of a relationship between two variables. Causation means one variable directly influences another. While correlated variables move together, they do not necessarily indicate cause and effect. Analysts must avoid assuming causation without controlled experiments or strong evidence. Understanding this distinction prevents incorrect conclusions and supports better analysis. Correlation helps identify patterns and guide further investigation, while causation explains why something happens. Clear understanding of both concepts is essential for accurate insights and responsible decision-making. 21. What are outliers and how do you handle them? Outliers are extreme values that differ significantly from the rest of the data. They may result from errors, unusual behavior, or natural variation. Analysts must investigate outliers to determine whether they are valid or incorrect. Handling methods include removal, transformation, or capping values. Outliers can distort averages, weaken model performance, and mislead conclusions. Proper handling improves accuracy and ensures meaningful insights. The approach depends on business context and data type, requiring careful judgment. 22. What is the purpose of hypothesis testing? Hypothesis testing evaluates whether a claim about a dataset is supported by evidence. Analysts use statistical methods to compare observed results with expected outcomes. The process helps determine if differences are meaningful or due to chance. It guides decision-making, validates assumptions, and supports experiments. Common techniques include t-tests and chi-square tests. Proper hypothesis testing requires understanding significance levels, p-values, and sampling. It helps organizations take confident actions based on data-driven evidence rather than intuition. 23. What is the difference between supervised and unsupervised learning? Supervised learning uses labeled data to train models for prediction or classification. Examples include regression and decision trees. Unsupervised learning uses unlabeled data to find patterns, such as clustering and dimensionality reduction. Supervised learning focuses on known outcomes, while unsupervised learning discovers hidden relationships. Both methods support analytics by improving forecasting, segmentation, and recommendations. Analysts must understand which method suits the business problem. Knowledge of both enhances ability to collaborate with data science teams and interpret model outputs effectively. 24. What is a KPI and why is it important? A key performance indicator, KPI, measures progress toward strategic objectives. KPIs provide clarity, focus, and alignment across teams. They help organizations evaluate success and identify areas for improvement. Analysts use KPIs to track performance, communicate results, and guide decision-making. Effective KPIs are measurable, relevant, time-bound, and actionable. They transform data into meaningful insights that drive business outcomes. Choosing the right KPIs ensures that teams prioritize the most impactful goals. 25. What makes a good data analyst? A good data analyst combines technical expertise with strong communication and business understanding. They know how to clean, analyze, and interpret data effectively. They ask the right questions, challenge assumptions, and look for meaningful insights. They can translate complex information into clear, actionable recommendations. Attention to detail, curiosity, problem-solving, and collaboration make analysts valuable contributors. Continuous learning and adaptability are essential due to rapid changes in technology and analytics practices. A successful analyst balances precision with practical impact. 26. What is the difference between data mining and data analytics? Data mining focuses on discovering hidden patterns, relationships, and anomalies within large datasets using algorithms and statistical methods. It is often exploratory and used to uncover insights not immediately obvious. Data analytics, on the other hand, involves interpreting, visualizing, and applying those findings to solve business problems and support decision-making. Analytics is broader, combining data mining, reporting, and predictive techniques. While data mining uncovers what exists in the data, analytics explains what it means and how it should influence strategy. Understanding both ensures a complete approach to extracting and applying data-driven insights. 27. What is exploratory data analysis, EDA? Exploratory data analysis is the initial process of examining datasets to understand their structure, patterns, and anomalies. It uses visualizations, summary statistics, and data profiling to reveal relationships, distributions, and outliers. EDA helps analysts determine the quality of the data and guides decisions on cleaning, modeling, and feature selection. It supports hypothesis generation and ensures future steps are based on accurate understanding. Tools like Python, R, and visualization platforms make EDA efficient and insightful. Performing EDA is essential for building reliable models, avoiding errors, and gaining a deep understanding of the dataset before formal analysis. 28. What is the role of a data analyst in a company? A data analyst transforms raw data into meaningful insights that support decision-making across departments. They collect, clean, and analyze data using tools like SQL, Python, and visualization platforms. Analysts create dashboards, reports, forecasts, and recommendations that help leaders understand performance and identify opportunities. They collaborate with teams such as marketing, finance, and operations to interpret results and drive improvements. Their role also involves ensuring data accuracy, identifying trends, and supporting strategic initiatives. Ultimately, a data analyst bridges the gap between technical information and business objectives, enabling organizations to operate efficiently and competitively. 29. What are common challenges faced by data analysts? Data analysts often face challenges such as incomplete or inconsistent data, which requires extensive cleaning and validation. They may encounter unclear business requirements, making it difficult to deliver actionable insights. Communication barriers between technical and non-technical teams can also slow progress. Managing large datasets, ensuring data security, and selecting appropriate tools or methods are additional challenges. Analysts must balance accuracy with deadlines while avoiding overcomplicated solutions. Rapid technological changes also require continuous learning. Overcoming these challenges requires strong problem-solving skills, adaptability, collaboration, and attention to detail to ensure high-quality, reliable insights. 30. How do you communicate analytical insights to non-technical stakeholders? Communicating insights to non-technical stakeholders requires clarity, simplicity, and storytelling. Analysts should focus on business impact rather than technical details, using visuals like charts and dashboards to make information easy to grasp. They should explain findings using plain language, highlight key takeaways, and show how insights support goals or solve problems. Tailoring communication to the audience ensures relevance and engagement. Providing context, examples, and actionable recommendations increases understanding. Effective communication helps stakeholders make confident decisions and strengthens trust in the analyst's work, making it a vital skill in data-driven organizations. Mastering these data analytics interview questions helps you present confidence, clarity, and strong analytical thinking. With preparation and practice, you can excel and stand out in competitive data roles.